Today I'm going to discuss the second problem of Leetcode BiWeekly contest 154, which is number of unique XOR triplets 1. So what is the problem? We are given an integer array nums of length n, where nums is the permutation of the number from 1 to n. A XOR triplet is num size or num j or nums k, and we have to find the number of unique XOR triplets for all possible triplets I, j, k. So let's take the second example, 312. Let's say 312. The possible XOR triplets will be ones or 1, or let's say ones or twos or three, like that. So you can see that here all the XOR triplets are mentioned. The possible XOR triplets value are 3, 1, 2 and 0. So the answer will be 4 because there are 4 possible XOR triplets. Okay. Now how we are going to solve this? So our first observation will be that this is a permutation, right? And we can take any I, j, k. Okay, I, j, k. So the permutation does not matter here. The permutation does not matter here. Only the length of the permutation or n matters. Okay, so only the length of the permutation ARR, the array length matters. Okay, so if we give any permutation of a given length, the answer will be same. This is the first observation. Second observation here is that let's say we have some value. Let's say like from 1 to, let's say 4. Okay, 1 to 4. Now let's say we fix one value as 4. We fix one value as 4. Now apart from that, the bitwise representation of 4 will be 1, 0, 0. Now we have something like 1, 2 and 3. So we can say that from 1, 2, 3, we can take any two values and generate the values from 1, 2 and 3. Okay, what I am going to say is that we can take any two values I and j, and we can say that I, i's or j, this set will contain all the value 1, 2, 3. Okay, now how I am coming to this conclusion I will explain later. Now let's say we have find i's or j, right? I's or j as 1, 2, 3. Now if we XOR this 1 with 4, we will get 5. If we XOR this 2 with 4, we get 6. And if we XOR 3 with 4, we will get 7. So let's say if we have something like 4, a power of 2 is present, then we can generate all the values from 0, 2 into that number, 2 into n minus 1. Okay, our n is 4 here. Okay, so from 0 we can generate 0 to 7 for given value of 4. Now for how I am saying that i's or j will contain all the value of 1, 2, 3. So let's say a value is k. Okay, k is equals to i's or j. Okay, now I will be nothing but k's or j, right? I will be nothing but k's or j. The pair is nothing but k's or j and j. Okay, now we can take any possible value j. We have set 1, 2, 3. So we can take any possible value j. Let's say j is our 1. Then k's or j will be different. K's or j will be different than j. Okay, I hope you get it. So we can for let's say k equals to 1. Let's say k equals to 1, and let's say we have taken j as 2. So we can say that 3 or 2 is equals to 1. Okay, so we have k is, let's say 1, then j is 3. We can, then our k or j will be 2. So that's how with the set I, j, we can generate all the possible value from 2 to the power n minus 1, 0 to 2 to the power n minus 1 minus 1. Okay, so n is the largest set bit. Okay, now that's the solution. Okay, if n equals to 4, we can generate from 0 to 2 into n minus 1. Let's say n equals to 5. So we will try to find that what is the largest power of 2 less than equal to n. Largest power of 2 less than equals to n will be 4. Then the answer will be from 0 to 7. The answer will be 8. Okay, I hope you get it. So we have to find the largest power of 2 less than equals to n, and the answer will be 2 into that. Largest power of 2. Largest power of 2. Now only edge case here is that, let's say n equals to 2. N equals to 2. Then the largest power of 2, which is less than equals to 2, it will be our is 2. Largest power of 2 LP2. Largest power of 2 will be 2. So you might say the answer will be 2 into 2, 4. But here this solution, this will i's or j, we will not be able to find. So our i's or j set will be i's or j will be 1, right? I's or j will be 1. But we will not be able to find i's or j with this one, because we can take 1. Okay, so we can say 1's or j equals to 1. 1's or j equals to 1. But here in that case j will be equals to 0. But we don't have 0 in the set. Don't have 0 in that set. So in that case the answer will be 2 here. answer will not be 4. This is only edge case. If n equals to 2, answer will be 2. Otherwise, we have to find the largest power of 2, and n equals to 3 is also kind of a edge case. N equals to 3, the answer will be 4. But n equals to 2, our answer will be 2 only because we don't have 0 in our set. I hope you get it. This is the edge case. You have to just find that edge case, but the rest of the idea is simple. That we will take one element and we'll take the complement of it. The element and the complement of it will be present in the set. Okay, that's why we will able to generate all the possible values with the last two set bits, and we'll XOR it with the this bit, the last bit 4, and we'll be able to generate all the numbers from 0 to 7. Okay, I hope you get it. So let's jump into the code. So here I am finding, this is the brute force solution I have written to verify my code. This is the brute force code. Now we'll take, if n less than equals to 2, we'll return n. Otherwise, we'll try to find the maximum value, last significant bit, which is greater than n. Okay. If 1 less than equals to I is greater than n, we'll just find max equals to I. Okay. So 2 to the power, let's say 2 to the power 2 is greater than n, 3, then the last significant bit will be 2. So in that case, we have to return 2 into 2, 4. Sorry, 2 to the power 2. Okay, we have to return 2 to the power 2. I hope you get it, because we are finding the last significant bits where 2 to the power L is greater than n. Okay, in that case, we have to return 2 to the power L. I hope you get it. The problem is quite interesting. The time complexity of this problem is order of log n. The third problem is quite similar also, but in that problem, instead of permutation, we are given an array nums, and the nums of size, let's say 0 less than equals to n less than equals to 1500. So we can use brute force to calculate every triplet. Okay, so you can see that I XOR j will be from 0 less than equals to I XOR j less than equals to like 1500 around. So we can create this set I XOR j, and then we'll iterate over k, and we'll try to find I XOR j XOR k. So I am not going to explain the third problem, that is a brute force solution. You can take a look at others code. The brute force solution I'm not going to explain. This problem have some interesting observations. That's why I have explained this problem. I will attach the link of the code in the description box. You can check that out too. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.